All right, boys and girls, welcome back to the drive-through Monday edition. Tough stuff. So, shout out to being challenged. Here we go. I already had you guys copy this down in your notes. Okay, maybe you just took a picture with your phone, but you're definitely going to need to rely on this little series of directions. Okay. Also, your graphing calculator, as it says down here in the final bullet, is your biggest help. Not only the calculator part, the graphing part, but also the table. You'll see some little hints in the table as well, okay? And if you take your time on these and do as much work as you can, you should be able to get minimally some significant partial credit on every single question, which would avoid any disasters on this quiz that we have coming up, okay? So we've got the evens on today's worksheet. We're going to work through them. Remember, the first step it says is to factor everything. So there's nothing you can factor on this one, so that step is done. And then the next step it said, I believe, was to cancel. Let's take a look. Factor, cancel, okay. Find your vertical asymptotes, and then that's about it. So, no factoring, no canceling. So this one's actually one of those that's kind of so simple that it's a little weird. Okay, so I'll just tell you right now. I put this into my graphing calculator. There were no horizontal asymptotes. And I'm just kind of saving you the time to do that. As I stated, we are going to ignore the range on all these. I think the range is the hardest aspect to teach, and I don't even think the teachers that are teaching range in this section are doing it right. They're skipping this little part, and I don't want to do that. I'm just going to skip the whole thing. Okay, so that leaves us with vertical asymptote, holes, and the domain. Did we cancel anything? So there's no holes. Okay? Where would the bottom of the fraction, the denominator, at what value for x would it equal 0? That's right. So we're going to have a vertical asymptote at x equals 2. And then the domain is all reals except x cannot equal 2, okay? All right, moving on to number 4. Now, a couple things. One, you might want to factor this. If you do, good. It looks factorable, okay? But only if this was a minus would you be able to factor it. Another way to think about this is there any number that you can put in for x, take it to the 4th power, and have it be negative? There's not. So actually, this is not factorable, and there's nowhere that the bottom can be 0. The bottom is always positive in this one. Okay? So this one's even actually stranger than the last one. Again, I'm saving you the trouble to do this because I already did it. I literally was working on this before we started class, and when I was confused about vertical and horizontal asymptotes, I put this graph into my calculator. There's no vertical or horizontal asymptotes. Okay? Did we cancel anything? We didn't cancel anything, so there's no holes. So then what's the domain? All real. So that was kind of a weird one. Did I skip 6? Maybe it comes next. Nope. Is there a 6 on there? Yeah. Okay. Let's go back. Let me pause this real quick. All right, so once again, this looks like it would be factorable. You have a squared and now you have a minus. But you're essentially looking for two numbers that multiply to be -2 and add to be 0. And those numbers don't exist. So this is not factorable. So we can skip past the first step. Okay? And then we can go on to canceling. There's nothing to cancel. So we can skip the second step and go on to finding our vertical asymptotes. Okay? So what value for x will we put it in the denominator to give us 0? So that's going to be x equals -2. We did not cancel anything, so we do not have holes. We'll get there. The next couple will have them. Okay? I don't know if this has a horizontal asymptote or not, so what I'll do is I'll graph it on the video. But I do think I can now find my domain. What's my domain? It's reals with x not equal to -2. So let's open up the graphing calculator and graph x squared minus 2 over x plus 2. Jacob, would you mind hitting the lights? Thank you. X squared minus 2. Oh, hold on. We got to put that in parentheses. So remember, you got to use parentheses well on this stuff. X squared minus 2. Close them. And then divide that whole thing by parentheses x plus 2. Okay, so notice you can see here's where our vertical asymptote is, and that's good. It looks like it's at -2. Can you see that? But there is no horizontal asymptote anywhere. In fact, when you get to calculus, maybe, I don't think this is important anymore, but they might teach you there's actually a slant asymptote here, but we are not covering that in this class, just so you know. But there's a line. It has to do with the top and bottom of the fraction, and there is a line where there's an asymptote here at a diagonal, but we're not going to go into that. So this gets us enough to answer the question. There's no horizontal asymptote. Okay? And we'll move on to number 8. All right, finally. Now we can follow the steps. Almost. Okay, so this one we can follow all of our steps on. The first thing we're going to do is factor it. How do you factor x squared minus 9? Do you remember this? Good. That's a good guess, but it's wrong. It's not x plus 9, x minus 9. It's x plus... That's right. That's fine. Okay? Got it? You're essentially looking for two numbers that multiply to be -9 and add to be 0. Alright, so now we're at that. Don't erase things. You cancel things. So the step 2 said to cancel things. Now remember, why can you cancel things? Because something divided by itself equals 1. So now put a 1 in up there because you're going to need that. Okay? You could put a 1 in for the bottom, but you don't need the 1 on the bottom. You're just multiplying 1 by x minus 3, okay? All right, now we can just start to figure this out. So, let's see. Vertical asymptote will be at, the vertical asymptote is the one that doesn't get canceled out. So it would be 3. Okay? Yes. Excellent question. The question is, why isn't there a vertical asymptote at -3? Because the -3 has been taken out of our equation, okay? However, it did exist, and that is what creates a hole. So the hole is at x equals minus 3. The thing that gets canceled is what creates the hole. Okay? If you would put a negative 3 in for x in your original equation, it still would have been undefined. But that's not an asymptote, it's a hole. And we'll show you that when we graph it. We're going to graph this one. Okay, remember that we are just ignoring the range. So I think we're ready at this point to go into the domain. That is correct. The domain would be all reals. X cannot equal 3 or negative 3. So both the hole and the asymptote get taken out of our domain because we're not allowed to put them in. Okay? So I think this one is going to have a horizontal asymptote at y equals 0. Because essentially we are graphing y equals 1 over x minus 3. Okay? But let's put it in. Let's put our new equation in to see what our asymptote is. Y equals 1 over x minus 3. Parentheses, don't forget your parentheses. And it does. Okay? It's got an asymptote at y equals 0 because at that point, this starts to look like the same graph that we learned in 7.2, which you'll be reviewing tomorrow. So our horizontal asymptote is at y equals 0. And these are not easy, which is why we're doing so many together. So let's keep going. All right, step 1, factor. I can tell you can factor the top, but you cannot factor the bottom. So this is going to turn into y equals x minus 2 times x plus 2 all over x squared plus 4. Okay? Now, the factoring in this one ended up not getting us anywhere because nothing canceled. Notice, there is nothing you could put in for x to make the bottom equal to 0. Okay, so nothing cancels. Is there any value for x that I can put in for x and get 0 on the bottom? No, because 2 squared is 4. What about negative 2? Negative 2 squared is 4. There's nothing. This one's a none, none, none. Okay? Yes?
So an indicator for factoring is a negative number after the...
Excellent. The question is, an indicator for factoring is if that is being squared, that is negative, and that is a perfect square. That's called a difference of squares, okay? Another great question is, what will this graph look like? Let's take a look at it, even though we're not being asked to graph it in this one. So x squared minus 4 over x plus 4. You got to put the top in parentheses. So parentheses, x squared minus 4, close it, divided by, parentheses, x squared plus 4. And I'm saying I might be wrong. There might be a horizontal asymptote here. So, but it's okay if I'm wrong. No, no. And I'm not even. I don't think that. I think this is just a very slightly increasing graph. I don't think that's a horizontal asymptote. I could look at the table, but look at that. That's a very strange graph. And I'm not even going to worry about the horizontal asymptote, because if I do, I got to go into calculus and L'Hopital's rule to tell you why. That's just not what we're here to do today. But good question. Okay, now we're into the graphing ones. So we'll do these two together, and then you guys will have a few more to do on your own. And then tomorrow you'll really get your practice with Math Excel. What's that? Well, you can go back and do number 12 on your own. Okay, so I think I could figure out vertical asymptote, right? Anybody know where that's going to be? Yep. X equals 4. So then I think that'll lead me to the domain. It's all the reals with X not being 4. There's nothing to cancel, do you agree? So we have no holes. And I don't know about the horizontal asymptote, so I got to wait till I graph this thing. So we're going to graph. Yes.
Even if you don't have to use parentheses, is it still safe and
Yes. Yeah, I would use parentheses on the top, even if you're not sure, because it can't really screw you up, but it can if you don't. So what we're saying here is we're taking. Let me just explain something real quick, why this is confusing to you. The reason this confuses you is this division bar. So we got lazy over time, and we decided instead of writing this as x plus 2 divided by x minus 4, mathematicians who make the rules but are also very lazy people were like, well, that's much easier to write just like this. Do you understand? But in that process, they lost that you're taking all of this divided by all of that. This long division bar accounts for that, but it doesn't help you put it in your calculator right. That's what you have to understand. Okay? So, back to the calculator. X plus 2 divided by x minus 4. And let's x plus 2. That's right, isn't it? It is x minus 4. All right. So let's see. We have an asymptote at, looks like at 1. So let's take a look at why that is. Let me go second table and find out. See how on the right it keeps going up and getting closer and closer and closer to 1, but it's never getting there? Can you see that? That's how I'm figuring out that we have an asymptote at x equals 1. I don't know another good way to explain that to you guys, and I don't think that I will be focusing too much on that when I grade your assessments, but in general, graph it, recognize, oh, there is an asymptote, and then just see if you can figure out what it is. It's the best advice I can give you for right now. Okay, so the horizontal asymptote is right here, so I will dot that. And the vertical asymptote is here. Okay, it's at y equals 1, and I'll graph this thing in blue. Let me go back to this. Okay. Go to my table, just plot some easy values. So negative, let's see, there's got to be some whole numbers somewhere. There we go. 1, negative 1, 2, negative 2. Three, negative 5. And then if you keep going, the ones down here will be nice as well. 5, 7, 6, 4, 7, 3. I would say that I want 4, But 6 helps me more, and I'll show you that here in just a second. 1, negative 1. 2, negative 2. 5, 3, negative 5. Now that I have 3 and I have my asymptotes, Alex, I kind of have an idea of what that path is going to look like. That's why I go to 3. 5, 7, 6, 4, 7, 3, asymptotes. Okay, and we got one more to do together. Y equals 3x minus 6 times x squared minus 4. Okay, step 1. Factor it. 3 times x minus 2 on the top. That would be an easy one to forget to factor. And on the bottom, what are we going to get? Oh, I think it is. X plus 2. X minus 2. Okay? All right. So, which one of those cancel? Those cancel. So now you got to identify which of those things on the bottom is an asymptote and which one is a whole. So the asymptote is this one. So where does this equal 0? That's right. So x equals negative 2 is an asymptote. Let me go ahead and dot that on before I forget. Okay? Whereas a whole would be this one. So there's a whole at x equals 2. We're not worried about the range in here. Okay? The domain, I know that x cannot be 2 or negative 2, but it's all the reals otherwise. So now we're going to use our graphing calculator to make up our table and find our vertical asymptotes. My suggestion, okay, is to graph the new equation because it's easier to put in your calculator. I would graph that. So y equals 3 divided by x plus 2. Let's see if it has a horizontal asymptote. It does. Okay, it's more expectable. And where is the asymptote at? Yep. Y equals 0. So let's dot that one. And let's go back to our table and find some values. Here we go. Negative 1, 3. And 1, 1. And negative 3, negative 3. Negative 5, negative 1. So Alex, notice in this one, there were only 4 nice points, so I'm only doing 4. Okay? Whoops, let me change this back to blue. And now you guys are able to graph some pretty funky functions. But we got one thing that I screwed up. I just realized it. But this is perfect, because this is actually how you're supposed to do this. Not screwing it up, but the process. Alright, when graphing a hole, you literally graph it and then erase it. So, there's a hole at x equals 2. So I got to go over here, and I got to take my eraser, and I got to hit that and mark a hole in that. And what that is indicating is you are not able to put in a 2 for x. Bless you. Because if you do, if you go back to the original equation, if you put a 2 for x, your calculator gives you an error. And that's why there's this little hole there. And that's why it's not an asymptote, because you could remove it. And eventually maybe this will be important to you. Otherwise, just do your best, show your work, get as much credit as you can. Sorry for the long video. Boom!